Hi everyone, I am Sadashiv and this is CineStream, a Netflix-style media discovery single-page application built using React, TypeScript, White, React Router, Axios, TMDB API, and Google Gemini. The goal of this project was to build a performant movie explorer while implementing modern front-end optimization techniques such as debound search, infinite scrolling, local storage persistence, lazy loading, and AI-powered recommendations. On the homepage, the popular movies are fetched over here directly from the TMDB API and displayed in a responsive movie grid. Each card contains movie poster, title, releasing year, and the rating, of course. To create more immersive experience, I also designed a cinematic hero section that plays a movie trailer in the background and highlights the feature content. So this is how it shows the poster at first and then plays the trailer. One of the key requirements for this sprint was to implement the debouncing, that is debouncing search. Let me open the network tab so that we can understand the debouncing, how it has been implemented. And let me search, like we can also come from here and this is where we can search. And let me quickly enter a movie like Spider-Man, let's say Spider-Man. So we can see that until I continue to type, um, the API request isn't being sent. Whenever I give or stop typing, the request is being made. Normally, an API request would be sent for every keystroke. For example, in the Spider-Man, for typing S or SPI, SPID, SPIDER. So this is how normally it would generate multiple requests. To prevent that, I created a custom debound hook with 500 millisecond delay. As you can see in the network tab, the application waits until I stop trying before making a single optimized API request. So example, or we can take another like Avengers. So until I hit Avengers, there will be no other request made to as a single letter. This is how the debouncing works, and it reduces unnecessary server calls and improves the overall performance. Let me maximize it again. Another part of the sprint was uh, infinite scroll. Instead of traditional page indentation, I implemented browser's native intersection observer API. So as we scroll towards the bottom of the page, the browser detects the target element and enters the viewport automatically, loads the next page of the movies from TMDB. The new movies are appended to the existing stage instead of replacing it, creating a smooth browsing experience without page reloads and visible layout shifts. I also implemented native lazy loading on movie posters, so images are only loaded when they are about to enter the viewport, reducing the bandwidth usage and improving loading performance. Next, we have favorites feature. This is what the favorite page looks like, and we can add the favorites by clicking on the heart icon, and the movie card will be saved in the favorites list. Let me add a few more and I'll show you where they are being stored. So in the favorites page, we can see that movie cards are being stored over here. These are stored on the local storage. That means even on refresh, they should still be the same. That is, data persists even after refreshing the browser. These remain intact. We can either remove from here or we can clear the favorites. So another feature we have is the final AI mood matcher. Here, users can describe their mood in natural language. For example, I want an inspiring sci-fi movie. So when we hit the enter, the prompt is sent to the Google Gemini, which returns a movie recommendation based on the user's input. The recommended title is then automatically passed into the TMDB search endpoint, matching the movie information and displayed instantly, like the movie poster and the movie title category of that. This creates a simple AI-assisted movie discovery experience. To summarize, Cine Stream includes TMDB API integration, responsive model discovery interface, debounced search with Axios, infinite scrolling, intersection observer, favorites page using local storage, native image lazy loading, Google Gemini mood matcher, AI mood matcher, and SPA architecture, React Router SPA architecture. So we also have the categories over here where, according to the genre of the movie, we can see the movies are being categorized. We also have another two categories where we have movies as a separate and TV shows as a separate category. And this is how the page and the application looks. Thank you.